Imagine throwing a dart, but you've taken the little fins off the back. Instead of flying straight, it's going to wobble, flip over, and completely miss the board. Now, put those fins back on. When you throw it, that dart slides neatly through the air and lands right where you aimed. So what keeps that second dart perfectly aligned? And why don't massive airplanes tumble through the sky in that same chaotic way? The answer lies at the very back of the aircraft. In aviation, this entire tail section is called the empennage. You can think of the empennage as the ultimate stability and steering center, located at the rear end of the airplane. To understand how this section keeps passengers flying safely, we can break it down by answering 4 simple questions. First, what gives the back of the airplane its specific tapering shape? The answer is the tail cone. Picture a falling raindrop. The water naturally tapers off to a point at the end to slip through the air smoothly. The tail cone does the same for the airplane, closing off the back end to reduce air resistance. Because this cone is mostly there to smooth out the airflow, it doesn't face the intense physical pounding the rest of the plane does. So engineers build it with fairly lightweight materials. That leads to our second question. Once the plane is moving, how does it stay steady instead of wobbling or bobbing? This is where the fixed stabilizers come in. These act like the fins on our dart. Looking at this tail section, you see 2 distinct parts, a vertical stabilizer standing straight up and a horizontal stabilizer laying flat. These parts are locked firmly in place to catch the wind, holding the airplane steady as it flies straight ahead. Together, the tail cone and these fixed stabilizers ensure the plane slips through the atmosphere smoothly and in a straight line. But if those parts are locked in place, how does the pilot actually steer? Attached to the back edges of those fixed stabilizers are sections that can move. These are the movable aerodynamic surfaces. Think about a boat. To turn it, you use a rudder at the back, swishing side to side to push water and change direction. An airplane uses the same logic. Its vertical rudder turns the nose left or right, and horizontal elevators hinge to point the nose up or down. Moving these surfaces catches rushing air, forcing the tail to move and redirecting the entire airplane. All that wind creates an immense amount of pressure. So what is inside this tail section that keeps it from snapping under the strain? If you peel back the outer skin, you'll find that the internal structure of the tail is built exactly like the wings. Underneath the metal skin lies a complex skeleton of spars, ribs, and stringers. As the wind bends and twists the tail, each framework piece absorbs a portion of that stress, transferring it safely into the main body of the aircraft. The movable surfaces on the outside dictate where the plane goes, but it is this hidden skeleton on the inside that ensures the tail handles the massive forces of flight. The next time you see a commercial jet, you can identify exactly what is happening at the back. You'll recognize the streamlined tail cone helping the plane cut cleanly through the air. You'll see the fixed stabilizers holding the aircraft steady, just like the fins on a perfectly thrown dart. And you'll spot the movable rudders and elevators catching the wind to steer the machine through the sky. By understanding these parts, you've mastered the anatomy of the empennage and taken a significant step toward understanding how flight actually works. If you enjoyed this breakdown, like this video and subscribe for more beginner-friendly aviation basics.